No, the thing is in A level, who is there to ask? Correct or wrong, you still must continue. Correct or wrong, you must still come out with the analysis one. Yeah, lor. So check with other classes what for what point. What's the point? Okay. Yeah. So can you tell each other, tell your neighbor, what's the difference between the term solubility and solubility product? Do you still remember what they are after 1 week? Actually, the next day already got people forgot what they are. Okay. So can you tell each other what is the difference between solubility and solubility product? And any conceptual difference? Any other conceptual difference? Can you tell each other? Okay, so can I hear from someone what is solubility? Okay, Zheng, tell me what is solubility. Not any amount, right? What is the amount? Maximum amount of the solid that dissolves to form 1 dm³ of saturated solution. All right, so solubility is the property of the solid. Okay, and it's essentially right equals to the concentration. For example, if I'm talking about calcium fluoride as my sparingly soluble solid here, then what I'm calculating is calcium fluoride. How many units of calcium fluoride, okay, that can be dissolved to form 1 dm³ of the solution. Okay, so this is equivalent to solubility. All right, so it's telling me how many units of this compound is maximum amount. How many, the maximum amount of units of this compound that can form 1 dm³ of the saturated solution. So that is solubility. Okay, so what is solubility product? Please take note, sometimes in A-level question, instead of using the term solubility, they use this instead. Yeah, so you must understand that when the A-level question asks for concentration of the whole compound of a sparingly soluble salt, we are referring to solubility. Okay, I repeat myself. Sometimes A-level don't use the term solubility. Instead, they ask you for calculate the concentration of this sparingly soluble compound in 1 dm³ of solution. Okay, so that is equivalent to solubility. Okay, so if you don't believe me, right, you can refer to the handout that I gave you this morning. The handout is A-level questions. So you can take a look at how they phrase the question. Okay, so you must understand what they're asking for. Okay, so what is Ksp? What is solubility product? What is solubility product? What is solubility product? It's a product of ions. Yeah, product of ions. So it is the big letter K with the subscript Sp. Then it will be the concentration of the cation, concentration of the anion. Okay, of course in aqueous medium and raised to the power of corresponding coefficient. All right, so that will be your solubility product. So it's a multiplication of the concentration of ions in the saturated solution. Okay, so what is the conceptual difference between the two? So Ksp, let's recall, any big letter K, Kc, Kb, Ka, all right, they are all related to what? Equilibrium constant. So they are all equilibrium constant and they will give a constant value at constant temperature, right? So this is the characteristic of all big letter Ks that you have studied. okay, from all the topics, relevant topics. Now, how about solubility? Is solubility only affected by temperature? So definitely it's affected by temperature. What else could have affected solubility? Huh? Le Chatelier principle, whereby we have, if we have changes in concentration of the ions, it can also cause the position of equilibrium to change. And that will definitely affect your solubility. So solubility is the position of equilibrium, while Ksp is a equilibrium constant. So they are slightly different. They are somewhat related, but they are different. Okay. So from the last tutorial, we have talked about question 3, question 5, and 4 and 6, right? So do you still remember what are the essential difference between these two groups of tutorial? Do you need me to elaborate? Clear already, huh? Because for question 3, part 4, and 5, part 2, right, we're asking for minimum concentration in order for the first trace of PPT to occur. Okay, whereas for question 4 and question 6, we need to consider dilution. Then we calculate the ionic product and compare with the Ksp value to predict whether precipitation will occur. Yeah. So are you able to recognize what's the difference now? Can All right. So let's look at number 3. Okay, calcium fluoride. Given that calcium fluoride is a sparingly soluble solid, okay, and HF is a weak acid. Predict the effect on solubility of calcium fluoride when pH of the solution is reduced. So what do you think will happen to the solubility? What do you think will be happening to the solubility? Increase or decrease? It will decrease. Why so? So if I talk about calcium fluoride being a sparingly soluble solid, if I want to write the equilibrium process, it will look something like this. Calcium 2 plus equals plus 2 fluoride equals, right? So this will be the equilibrium that we consider for solubility. Okay, what else do we need to consider? HF being a weak acid means what? It will undergo partial dissociation being a weak acid. So it will partially dissociate to form the H plus and the F minus. Agree? Okay. So given this situation, pH of the solution is reduced. What does it mean?
Concentration of H goes down.
Yeah. Concentration of H plus goes down. So when I say pH is reduced, what does concentration of H plus mean? Goes up. So concentration of H plus will go up when pH is reduced. Okay, so when H plus goes up, what will happen to the equilibrium number 2? Equilibrium number 2 will shift to the left, right? Okay, so when it shifts to the left, what will happen to the, how should we discuss about it so that I can talk about solubility of calcium fluoride? How should I discuss about it? Okay, there's no need for you to tell me that F minus is a common ion. I mean, it's good that you recognize. Okay, so it's a common among the two equilibria. Okay, so you recognize that it will be affected. So if I affect equilibrium 1, then definitely equilibrium number 2 will also be affected because fluoride is common. Okay, then what else must I say? So with increase in H plus, to partially offset the increase in concentration of H plus. So remember, when we talk about disturbance, we must refer to changes in concentration or changes in pressure or changes in temperature. All right. So telling me H plus increase or decrease not enough. You must talk about the concentration. Okay. So with increase in concentration of H plus, in order to partially offset that, it will shift to the left for equilibrium number 2. All right, I can say shift right or left because I've written down my equation. Yeah, so when it shift left, when equilibrium number 2 shift left, what is the consequence? Can you tell your neighbor? Can you tell your neighbor what is the consequence? Practice answering it. Okay, so equilibrium 2 will shift left. So therefore, it will cause your fluoride concentration to drop as well. So when your fluoride concentration drop, how does it affect equilibrium 1? How does it affect equilibrium 1? Equilibrium 1 will shift to the right to favor the dissolution process in order to partially offset the fluoride concentration. All right. So therefore, you can see from here that the reaction of the strong conjugate base fluoride by H plus, the removal of strong conjugate base by H plus will cause the calcium fluoride to enhance in its solubility. Okay? So this is one of the questions that is not addressed in the tutorial. All right, so this is the concept that is addressed last year in A-level assessment. Okay, so removal of strong conjugate base with the action of H plus, okay, is tested, you must know. Okay, repeat what? I said A-level tested last year. Huh? Strong conjugate base being removed by your acid H plus. Okay, so one of the sparingly, the anion of this sparingly soluble salt happens to be a strong conjugate base. Therefore, it can react with the H plus to be removed from the equilibrium. Okay, that's how it will affect the POE. Can? Yeah, being a strong conjugate base, fluoride. When I say strong conjugate base, okay. Strong conjugate base. Why is this a strong conjugate base? Because it comes from a weak acid. Yeah. Can? Okay, if there's no further question, then let's move on. So for this part, no problem, right? Can calculate the Ksp. Numerical answer is already given. Cannot calculate. Can calculate, right? Okay, numerical answer is already given, so I assume you can do it, right? So no problem. Yeah. So for next part, we are to work with solution A. Okay, so can someone tell me when you look at this kind of problem, right? What do you need to pay attention to? What is the most important keyword about part 2? What is your tutorial answer? Okay, so in this case, right, what is important keyword here? Right, you are told that solution A is saturated with both calcium hydroxide and calcium phosphate. So what does it mean? What's the point of telling this? What's the point of telling us this? Again, sorry. Okay, so from here we recognize that the concentration of calcium 2 plus that we calculated, right, will be communal, meaning it will be shared by the two sparingly soluble salt. Okay, by the two salt. Okay, what else? We recognize that there's a common ion. Okay, so therefore this calcium 2 plus is communal. Okay, what else? What else other than from here? What else should we deduce from here? Yeah, so ionic product must be equals to the corresponding Ksp value. All right, so that is the meaning of solution A saturated with both calcium hydroxide and calcium phosphate. Okay, next, the next piece of information is telling you that you are working with pH 13. Okay, and they are very nice. They calculate pH 13 hydroxide concentration for you. Okay, in actual fact, right, you should know how to calculate that. All right, so given that the Ksp of calcium hydroxide is 4 times 10 minus 5, how do you make use of this to calculate the concentration of calcium 2 plus in saturated solution? Yeah, so you should be making use of the Ksp expression of calcium hydroxide. So the calcium hydroxide of Ksp expression for calcium hydroxide will be as follows. Okay, so this will be equals to the Ksp value 4.0 times 10 minus 5. All right, so the next question is, okay, I know the expression. I know that they are supposed to be equal. Okay, then what do I substitute here? What can I find out from here? Yeah, so this concentration OH minus here, right, should be 0.1. Or do I need to multiply by 2? 0.1 as given here, or do I need to multiply by 2? Because every 1 mole of calcium hydroxide gives 2 moles of hydroxide. Do I need to multiply by 2? Do I need to multiply by 2 here? No, no need to multiply by 2 because the concentration of OH minus here is already the total concentration. The pH is already measured from the mixture being total by default. Okay, so you just need to substitute it inside, then you can calculate what is concentration of calcium 2 plus, which is shared between the two sparingly soluble salt. Can? Right, so you are able to calculate this, right? Okay, then after that, what do you do? After that, what do you do? Okay, so what's the answer to this part? So what's your calcium 2 plus? Oh, it's here already. 4.0 times 10 minus 3, right? All of you can get it. Okay, so with this in mind, right, how are we going to calculate the solubility of calcium phosphate? How do we do that? How do we construct the ice table? Do you always construct the ice table? Do you have the habit of constructing the ice table? Okay, so how do we substitute inside the ice table? How do we go about it? Yeah, calcium 2 plus is already calculated, right, from the above. So from here, I know that my concentration of calcium 2 plus is equals to 4.0 times 10 minus 3. Okay, do I need to multiply by 3? Do I need to multiply by 3 here? No need, because the concentration here is already the total. All right, no need to consider mole ratio. All right, then what is phosphate? How do I deduce the concentration of phosphate here? Do I know the concentration of phosphate? But it's related to the solubility of calcium phosphate, right? How is it related to solubility of calcium phosphate? How is it related? Yeah, so in the construction of the ice table at equilibrium, right? What will be my phosphate? So if this is my solubility, this will be minus S, right? Yeah, then phosphate will be 2S. So in this case, do I add 3S here? Do I need to add 3S here? Oh, because there's 3 moles of calcium 2 plus coming from calcium phosphate, right? So do I add 3S here? Yeah. Okay, so I need you to recognize that this is not necessary, because this is already the total. Not only communal, it's already the total. All right. So the 4.0 times 10 minus 3 is already inclusive of the 3S. There's no need for you to add the 3S to it. It's already inclusive. Am I clear on this? All right. So with this in mind, I can substitute and get the answer. Are you able to get the answer? Okay. Any question? Yep. Ice table for the first one, meaning? No need ice table. I already know that ionic product must be equal to Ksp. And I already know the concentration of OH minus. Ice table, then will it make any difference to the working? So what do you get? Calcium hydroxide in equilibrium with calcium 2 plus and the 2 OH minus. So what does your ice table look like? This one is 0.1? No? 0. Okay, then after that, 0. Hydroxide minus S plus S and plus 2S. Then you solve for S. Ignoring the fact that you are given hydroxide concentration. Do you know what's wrong with this method? Can someone tell Sijie what's wrong with this approach? Anything wrong with this approach? No doubt, hydroxide only comes from calcium hydroxide. So why can't you use the ice table approach to determine the concentration of calcium 2 plus? What's wrong with it? Who can tell him that? No. What's wrong with this approach? Huh? Pardon? Yeah. The thing is, right, calcium hydroxide is not the only source of calcium 2 plus. So here, right, you are already wrong. Yeah, it's wrong because you have to recognize that calcium is not only coming from calcium hydroxide, it's also coming from your calcium phosphate. So by using this and substitute into the Ksp value, you will end up with a wrong answer because this S here is not accurate. Yeah. So the only way to calculate the unknown calcium 2 plus must be using the known value of pH. Then you substitute to equate it to the Ksp value. Yeah, that's the only approach. Can? Any other question? Now, will I be able to obtain the calcium 2 plus that comes from calcium hydroxide alone? Can I calculate that? Can I calculate calcium 2 plus coming from only calcium hydroxide? Am I able to calculate that? How? Yeah, using the OH minus. So you can see that whatever OH minus obtained here must come from calcium hydroxide, right? So if I know the total concentration here, then half of it will be the calcium 2 plus coming from calcium hydroxide. Okay, I need you to recognize this. Okay, so obviously the calcium 2 plus that you have calculated earlier on must be larger than this value because it comes from two sources. Make sense or not? Yeah. Okay, so let's look at the next part. Okay, this part settle. Okay, no issues. Can? So let's look at the next part. Comment on and explain the discrepancy in the solubility. So right at the start of this question, you are given the solubility. Then in the next part, you're asked to calculate the new solubility in the presence of calcium hydroxide. Okay, so how will you explain that there's this discrepancy? Why is there a discrepancy? Yeah, okay, good job. So in this case, you need to recognize that you cannot just say common ion effect. You need to recognize that there's an additional source. Okay, and this additional source is coming from your calcium hydroxide. Okay, therefore it will disturb the equilibrium. So when I write equilibrium number 1 here, this also means that you have to write it as an equation. Okay, so you should write it for reference because we are talking about shifting right, shifting left. So it should be written down as a reference as well. Okay, so this is my equilibrium 1. If you're lazy to write the equation, then you should tell me whether it favors the dissolution process or precipitation process. Okay, so you can describe the process that is being favored, or you talk about the POE. Up to you. Okay, can? All right, let's move on. Okay, so let's look at the next part. Silver ions and thiosulfate reacts 1:2 ratio to form a complex ion. So can you quickly tell me what is the formula? Are you able to deduce the formula? Okay, what's the net charge of this formula? Ivan, what's the net charge? What's the net charge of this complex? Do you know what's thiosulfate? Okay, so what's the formula of thiosulfate? Thiosulfate ion only. I got Na2. S2O3 2 minus. So your silver plus is only one of it. Then there's 2 S2O3. Okay, so net charge of, what's the net charge? Yeah, 3 minus. All right, so this will be the formula of this complex. And this complex carries a net charge, therefore is soluble in water. It's described as a soluble complex ion. Okay, so with the aid of equation, suggests how the solubility is affected. So how will the solubility be affected? Increase or decrease? Up or down? Yeah, it will be greater. Okay, why so? Not just amount, refer to concentration. Yeah. Okay, so do you hear him? Do you agree with him? This is not the way you describe. Do you all hear him or not? Never. Huh? Yes. Gauri never hear you. Okay, so Gauri, how will you say it? So with the formation of this soluble complex, right? What effect does it have on the equilibrium? This equilibrium, we are talking about solubility of silver chloride, right? This is the equilibrium of interest. Okay, so how do you think it will affect the equilibrium? Right? You're having sore throat or what? Oh. So in this equilibrium, with the addition of thiosulfate, Ag plus or chloride that is being affected. Which concentration is being affected? Huh? Ag plus, right? So with the formation of this soluble complex, your concentration of Ag plus will drop at that moment. Okay? So if the concentration of Ag plus drops due to the formation of the soluble complex, the position of equilibrium for 1 will shift forward to partially offset that drop or decrease. Okay, so you will see silver chloride being more soluble as a result. Yeah, okay, so this is all in consistent with Le Chatelier principle. Okay, so remember, talk about the changes in concentration of silver plus, not just the number of moles. Okay, so that's the only thing I want to emphasize here. Again, sorry. No, it will be dissolved in this form. What do you mean by it go back? Yeah, it's an equilibrium between these two. Silver plus aqueous plus 2S2O3 2 minus is equilibrium. Yeah, but with the addition of this will drop due to the formation of this complex. Yeah, so no matter what, the concentration of silver plus will drop. Therefore, equilibrium 1 will move forward. Yeah, so when equilibrium 1 move forward, solubility is enhanced. Yeah, okay. Any other question about this part? Okay, let's move on. So let's look at the next part. Okay, so are you able to calculate this? Are you comfortable with calculating this? Can or not? Go through. Okay, so let's look at this. You are given this number of moles of silver chloride solid, added to a total of 2.5 cm³ of thiosulfate solution. Okay, then you are told that 1.8 times 10 minus 5 remain undissolved. So remain undissolved means what? This amount is still solid. right? So this is the amount of silver chloride solid. Okay, then this is the total amount before it dissolves, before it's added to the aqueous sodium thiosulfate solution. So am I able to calculate how much of silver chloride dissolved? Can I or not? The scenario is I have silver chloride solid, then I'm adding this 7.00 times 10 minus 5 into a 2.5 dm cube of thiosulfate. Okay, then after adding stir for a long time, make sure equilibrium is attained. Then I discover that the solid is 1.88 times 10 minus 5 undissolved. Okay, so how do I make use of this information to calculate the amount of silver chloride dissolved? Can I do that? Just take the so just take the difference. So from taking the difference, you will be able to calculate the amount of silver chloride dissolved. And from there, the concentration of the chloride present. Okay, so this one is concentration. Concentration, then you have to take the 2.5 dm cube into account in order to calculate the concentration of chloride. Yeah, so are you able to calculate that? So amount is number of moles, concentration is different. You have to take the total volume into account. Okay, per dm cube. So can do so? Do you need me to show? Okay, let's move on. Okay, so let's look at this. By making reference to the Ksp value of your silver chloride, the concentration of the chloride that is calculated in part A determine the concentration of the free silver plus ions in the solution. So basically, do you have difficulty calculating this? So what is the calculation behind? What is the chemistry concept? What's the chemistry concept? Are we looking at a saturated solution? Are we looking at a saturated solution here? We are, right? Because we are told that there is 1.88 times 10 minus 5 mole of silver chloride remain undissolved. So the fact that you have silver chloride remaining undissolved means that this must be a saturated solution. So if it's a saturated solution, then what is the significance? Yeah, ionic product must be equal to Ksp. So with this in mind, the chloride concentration can be calculated from above, right? Yeah, so with that concentration, you can substitute into the Ksp expression. So this value is 2.05 times 10 minus 5. Then you equate it to the Ksp value of your silver chloride, which is 1.8 times 10 minus 10. Then you should be able to calculate this. So this is the calculation approach. So you must recognize that this is saturated, therefore ionic product equals to Ksp. Okay? Right? So if you're not stopping me, I'll assume you are able to do okay or not? Okay. Then the next part is how do you calculate the concentration of the complex silver ions? How do you approach this? How do you approach this? Now, this is free silver plus ion. Now, why do you think the question used the term free? What does it mean? They are on their own, free. Okay, that means they are not bonded to your thiosulfate. That's the meaning of free here. Okay, so this is free silver plus without the thiosulfate. Okay, but when I make use of this term total Ag plus, what do I mean? What does the total Ag plus in this solution mean? Yeah, so it will be the silver plus that is free as well as the silver plus that is with the complex. This is the meaning. Okay, so this is the total Ag plus that we are talking about. Okay, and do I know what is the total silver plus? Do I know? Do I know? Okay, how do I know that? Solubility, to be obtained from solubility. Yes, Guo Chang? Chloride. Okay, so it will be equal to the concentration of chloride. Can you explain to the class why so? Yeah, so your original sparingly soluble solid is 1 cation to 1 anion. So upon dissociation, they should give you the same ratio. Yeah, so the total concentration of chloride obtained in part 1, right, should be telling you also the total concentration of silver plus. Yeah, okay, but that will be consisting of the free silver plus as well as the complex silver plus. Okay, so you can see that this is already known from part 1. This is known from part 2. Then are you able to calculate this? Yeah or not? Can calculate this? Can calculate, so I move on. Okay, so additional practice. I didn't ask you to do question 11, but it should be fine, right? Question 11. So what is the calculation approach here? Do you need to do any calculation? For MCQ 11, do you need to do any calculation? Yes or no? To deduce which one is the least soluble, do you need to do any calculation? No? Yes, you need. Why? Why do you need to do calculation? Yeah, so first two is 1:1, but the last two is 1:2. Okay, so therefore you need to calculate what is the solubility of each solid. Then you can make a fair comparison of which one is the least soluble. All right, so question 11, you have to calculate the solubility. All right, so for question 12, do you have problem? Are you able to deduce the answer? Okay, for question 12, you have to recognize that solubility of iron carbonate in water is this. Okay, and you are asked to calculate solubility product for iron 2 carbonate when it is dissolved in iron 2 chloride, which is in the presence of a common ion. So one thing you need to take note of is what? Ksp is not affected by the common ion effect. So you could jolly well use the solubility in water to calculate the Ksp value already. You can ignore the second part of this question because it will not affect the value of Ksp. Yeah. So the second statement here, right, is a redundant information. Yeah, it has no effect on the Ksp value. So you can just calculate the Ksp value from the original first statement. That will do. No need, because Ksp is not affected by whether there's common ion or not. Yeah, so definitely when you put iron 2 carbonate in iron 2 chloride, the solubility will decrease, right? Am I making sense or you are confused? So solubility will be affected, but Ksp will not, because Ksp only depends on temperature. As long as temperature is constant, Ksp remains constant. So notice that I emphasize 25 degrees Celsius. I emphasize 25 degrees Celsius again. Yeah, do you see that piece of information? Temperature is deliberately kept constant. Yeah. Okay, so with that in mind, you should recognize that I can calculate Ksp from the first sentence, and it will be the same in the presence of iron 2 chloride. Solubility squared, yeah, because it's 1:1 ratio. Can? Okay, so for question 13, if you have done it, do you have any question that you want to clarify with me? Did anyone do it? I didn't ask you to do that. Okay, never mind. No question, right? Okay, so let's look at the next part. Okay, 14, do you need me to explain anything? Question 14? No need. Okay, let's just. Okay, so how about 15? 15. Okay, so in this case, right, first of all, you are doing selective precipitation. Are you able to recognize that this is related to selective precipitation? Can you recognize? Do you know why is it selective precipitation? There is a mixture of 2K ion. There's a mixture of 2K ion. In the same solution, you have magnesium 2 plus and copper 2 plus swimming around in the same space. Okay? Then you are adding sodium hydroxide bit by bit until a total of 40 cm cube is added. Okay? Now, can I ask you to imagine the scenario as I gradually add sodium hydroxide to it, right? Which one will be precipitated first? Magnesium hydroxide or copper hydroxide? Huh? Yeah, CuOH2 will be the one that will be precipitated out first. How do you know? Because the Ksp value is smaller, right? Yeah, Ksp value smaller, and some more they are 1:2, 1:2 ratio. So the ratio of cation to anion is the same. Yeah. So in this case, I can just compare the Ksp value to deduce which one is less soluble. So I will expect copper hydroxide to be precipitated out first. Okay. So this means that my copper 2 plus concentration will drop, right? Agree? If copper hydroxide is to be precipitated, my concentration of copper 2 will drop. Agree or not? So this is, I don't know how much you drop by, unknown. Okay? But I'm told that at the moment of adding 40 cm cube, my magnesium hydroxide starts to precipitate. So is this piece of information very important? Is this piece of information very important? Very important. So what's the importance? So this means that the ionic product of magnesium hydroxide must be equals to the corresponding Ksp of magnesium hydroxide. Yeah, okay, so this is the what you can conclude from here. When magnesium hydroxide is about to precipitate, ionic product must be equals to the corresponding Ksp. Okay, then what happens? Then what do I do next? What do I do next? Huh? Then what do I do next? So in this case, right, ionic product will be magnesium 2 plus and the hydroxide concentration square, right, equals to the Ksp value of magnesium hydroxide, which is 6.3 times 10 minus 10. Okay, then what next? So do I know magnesium 2 plus or do I know hydroxide? Which is the one that I know? Magnesium 2 plus. I know magnesium 2 plus. How come? Why do I know that? Because when magnesium hydroxide is about to precipitate, this means that this is not precipitated yet. Okay, so therefore you can use 0.2. But then you have to take into account that there's dilution. Okay, so there's dilution. So the total volume now at this moment in time is 140. Yeah, the total volume at that point of time is 140. So you need to consider dilution. So 0.2 times 100 divided by 140. So this will be the new concentration of magnesium 2 plus upon mixing. Okay, then you can calculate hydroxide square, unknown, and equate it to your corresponding Ksp value. I think that's what most of you have forgotten. You forgot to consider the dilution factor. That's why they give you the volume. The moment they give you the volume, right, likely that you need to consider dilution. So this is something that you need to remind yourself. Whenever there is volume given, think along the line of dilution. Can? All right. So once you got the concentration of hydroxide here, are you able to calculate the copper 2 plus concentration? Can or not? Huh? 2OH is coming from sodium hydroxide. Sodium hydroxide is the source of hydroxide here. It's not coming from your magnesium hydroxide. You are precipitating magnesium hydroxide, but it doesn't mean that the hydroxide is coming from magnesium hydroxide. So we are working with two solutions, trying to form magnesium hydroxide PPT. So the source is coming from sodium hydroxide, not from your calcium hydroxide. So don't need to multiply by 2. Okay, so are you able to calculate the answer from here? Can not? Okay, so with that, then let's move on to the next part. Okay, question 16. Do you manage to try it? All right. Oh. So we have some time. You want to try it now? Where's your tutorial answer? Where are all the calculation? This is only the front part. How about those at the back? Then what happened to all this? Then when I go try it, why didn't you scribe? I don't again.
I did write down something.
Where? If not, then how are you going to get the answer here?
Because I'm intending to also like do myself later.
But then you must also know the thinking process, right? Must scribe the thinking process, right? Yeah. And also, if you don't scribe, there's nothing for you to revise. Yeah, make it a habit. Huh? Yeah, for those who miss the practical on Monday, makeup will be on Thursday. CM4 7:15. Nash, are you able to make it Thursday? But makeup practical overrides CCA. Yeah. 7:15, because you need time to do the revision prep. Yes?
The precipitate refers to the residue.
Precipitate refers to the residue. What do you mean? Yeah, precipitate is the residue.
What's the recipe?
What do you mean? Oh, what is the sparingly soluble solid? Eh? Saturated solution of lead bromide. Read the question. The filtrate can be regarded as a saturated solution of lead bromide. So lead bromide is the sparingly soluble solid.
It's not the recipe, it's the filtrate.
Yeah,
The 2 grams refers to the recipe.
lead bromide. No? Lead bromide solid in equilibrium with the saturated solution. No, you read the whole question. 25 cm³ of the river water was collected, 50 cm³ of lead nitrate was added. The precipitate form filtered off 3 grams of the PPT. Okay, so you have to recognize that all nitrates are soluble. Yeah, so it's the lead 2 plus bromide. Yeah. Then there's this part here, the previous paragraph. Bromide ions are thought to be one of the N ions present in abundance. Concentration of bromide is used as an estimate of concentration of ions. Mhm.
To refer to what is left in the paper.
Yep. The lead bromide solid.
But what is this?
Lead bromide solid, no? Because you are talking
Oh,
of yeah. Sit down straight. If not, then you sleep. So how do I calculate the concentration of lead 2 plus in the filtrate?
Plus.
Yeah. Total mole of lead 2 plus, it will be equals to 50 over 1000 multiplied by 1. Okay, so that will be 0.05 lah. So that is total mole before precipitation. Okay, then after you add the two together with the river water, 25 cm3, it will cause precipitation. So this is 3 grams. Yeah. So how does that help me determine the lead 2 plus in the filtrate? Yeah, so to determine the number of moles of lead 2 plus in PPT, it will be 3 divided by molar mass of lead bromide. So how do I calculate that? Can calculate, right? Then after you have calculated this equals to Y, then you subtract it from silver lead 2 plus, still in solution, it will be equals to 0.05 minus away your value Y. Okay. Then after that, is that our final answer? That's the mole. So to determine the concentration of lead 2 plus, still dissolved in solution, what do I need to do? Yeah, 0.05 minus Y divided by the total volume, 75, times 1000. So that will give me the final answer. Okay, for this part. Okay. So are you able to calculate that? Yeah. So will you be able to calculate the Ksp value? Don't need, no, the next part. Right, the Ksp expression. So this one should be quite straightforward, right? Ksp expression, there will be your concentration of lead 2 plus, concentration of bromide square equals to your Ksp expression. Okay, then you are given the numerical value, determine the concentration of bromide in the river water.
When you say expression, we don't need to find the numerical value.
No need, because it's given in the next part.
So
Yeah. So are you able to calculate? Can. This one. So remember, this concentration here, you have to determine it in the original 25 cm3, not the total of 75. So if you have calculated using the total 75, you end up with the wrong answer. Are you able to do it? Can. All right, so that's all for today. So today we'll start off with the money cash collection for Fantasia. Then we'll go to LT1 for the second half hour. Yep.